in the center.
really?
So,
Good job.
I took
Go
class,
team.
but in Glaze, it was just the clay.
So, let's see if we can summarize basically what happened in part one. I'm just going to mostly be talking to you. So, in part one of this class, we started by looking at studio glazes and identifying what the water content is and the effects of water on how a glaze performs.
okay.
When I talk about defects, it's not just what the glaze looks like coming out of the kiln, but also process defects, how it is to work with. Does it settle in the bucket? How does it apply? How is it to handle? Are any of the materials unavailable, expensive, toxic?
What it can be applied with? Like
Sure, yeah.
Brushes, does it work with a brush?
Yeah.
Does it
How
work-
are you applying it? Pretty much we've only really addressed dip application. We did play around with flocculants and deflocculants, Epsom salt, Darvan. Last time we even played with some gum. And
Play with gum sounds like fun.
yeah, to kind of see how those things can affect the viscosity or the fluidity of the glaze. So the tools we use, as opposed to a graduated cylinder, I use an Erlenmeyer flask for measuring specific gravity, which is the water to solids ratio, and use a Zahn cup or a Ford cup for measuring
You got the
flow
Ford truck.
or the viscosity.
Yeah.
Well, I bought another one. I
Yeah,
couldn't
you
find.
said you were gonna. Yeah.
Yeah, I couldn't find the one from the first time I taught the class. It disappeared. But
Does it have a hole in the bottom?
yeah, they both have holes in the bottom. So
Okay.
you're filling them with glaze, and you're timing to see how long it takes for it to flow through,
I see.
and that measures the flow or the viscosity of the slurry. So there are, when identifying kind of the qualities of a glaze, we're looking at each of the life stages. So the green properties, the storage properties, application, firing, and final appearance. And we started with this kind of like questionnaire, which just helps you to identify where there's room for improvement in a glaze. And so it's kind of identifying, helping to get you to have little like red flags that pop up if you're in the middle of making a recipe, and you're making a substitution of a material because like Custer Feldspar is no longer available, that you're actually like making note, like there's no EPK at the studio here, it's been switched to tile 6. So these kinds of things, you might be making an adjustment or a substitution, and it's just an opportunity for you to make notes and identify those changes as they come about. The other thing with making glazes is batching order. So as opposed to taking all the dry materials and mixing them together and creating a big dust cloud and adding it to water, we add the dry materials into the water and in a specific order. So I created a sheet here of what kinds of materials should be added first, second, third, fourth. So you're reorganizing the materials as they're written, and that actually aids in how easily the materials wet and mix up and sieve.
Okay, so there's actually hydrophobic materials that we're using.
Yep, hydrophobic materials, a couple of them would be like bentonite, talc, magnesium carbonate, wood ash. Those are all pretty hydrophobic materials.
Okay.
And so
basically they don't
wet easily.
wet easily.
Yep, so if you put them into the slurry later on, then it's much harder to get them to incorporate, it's much harder to sieve them, And so by getting them into the water earlier in the process and then dumping heavier materials on top of them, it kind of forces them down into the water, gives them more time and more available surface area in contact with water.
And you start with the ingredients that'll actually dissolve in the water.
Yep. Any soluble materials, borax, soda ash, those the flocculants and deflocculants, things that are going to affect the flow, getting those in first. And then clays and hydrophobic materials. One of the functions of clay in a glaze recipe is to help keep everything else in suspension. So most recipes written in books do not have water and do not have a batching order.
That's what I noticed.
Yeah.
Never,
Yeah.
percentage of water, usually that's kind of like, you add that after, or you add that to,
You do it to
the right-
feel,
right,
which
to the right
is
feel.
very subjective. Yeah. Did
Well,
I?
You can get results, but they're not real as consistent.
From user to user, yeah. I mean, if
Or
you,
even if I make it
Sure.
twice.
Yep.
Because I used
but
to
yes,
do a lot.
yeah. Specifically, when you have multiple people making glaze, using glaze, community setting, it's nice to have a benchmark that you can then check a glaze that's out in the studio and know if it needs to have water added and how much.
We did look at the specific gravities, so they probably weren't ridiculously off. But
Yeah. So that was the first part of round one. Sorry, this is kind of just like a recap, just to catch everybody up to speed and get you back in the mindset of your brains just being kind of packed. The second thing we did is we took a recipe after identifying the target specific gravity and water content, and we did an elimination test. And so that is taking the recipe and making several batches, eliminating one ingredient from each of those batches so that you can, by its inverse, understand what that material is adding to the recipe. So we have an example over here. We have a partial example over here. This is Burke's Celadon, and we're missing a couple of data points. I don't know where they went. This one is complete. This is the Soto Green. And so this is taking out the OM4 ball clay, taking out the EPK or the tile 6 kaolin, eliminating the Minspar sodium feldspar, taking out the red iron oxide, taking out the cobalt carbonate, taking out the whiting, flint, and Frit 3124. What we were determining last session was we were seeing how the recipe is performing. We identified the water content at 65% was working well. The EPK and the OM4 ball clays were kind of performing the same function in the recipe. And so, and similar results. We found that remixing the glaze with the OM4 was easier than the EPK. So we did a substitution and eliminated the EPK and doubled up on the OM4 ball clay just to simplify the recipe by one ingredient with no adverse side effects. So we went from 7 ingredients down to 6 ingredients. From there, this was more a personal beef of mine, is Soto Green is not green. And so we took the cobalt carbonate and we did a reduction test using this base without the EPK. So we did the cobalt carbonate at 25, 50, and 75% of the original recipe. So we got a spectrum there. What we were then identifying is where the glaze is pooling, there is some cloudiness, and on top of the test tile, there was some pitting or pinholing. And so we went back and we looked at the other ingredients to try and identify which one was responsible for the pitting and pinholing. We identified that as the flint or the silica. So we liked the color of the cobalt at the 50%. We were getting a green color, and we were trying to eliminate the cloudiness and the pinholing. So we did the flint at 75, 50, and 25%. We found that at 50%, the cloudiness went away, and the pinholing went away.
So it was responsible for both those defects?
It was. Where we left off last session was we said those defects went away, the color was fixed, the recipe was reduced by one ingredient, and we were seeing a little bit of crazing. So where we left off and had not yet tested was to say what other materials could be responsible for crazing. And we thought that the frit, although it's a little hard to tell because this is quite dramatic, we were going to take this and then branch off and do a reduction test of the frit to see if we can,
That's the crazing there?
yeah, if we can eliminate the crazing and possibly reduce the melt by a little bit, because the original recipe has a little bit less melt. Keeping the glass clear and bubble free, and see if we could eliminate the crazing. So that's where we left off last session.
Where's the crazy? What's it look like?
It's the little crack lines.
It was a group effort.
Oh,
That's nice work.
So that was a lot to did you follow all that? Rob?
So this is the pinhole that
Which
you're
is the one
talking
out of the
about.
bucket?
Yep.
Did you do, is there a test tile this
Yeah.
is what it looks like out of the bucket, which is the one
This one.
that's
No.
the
This one.
There's
This
no,
is
top
the
one.
there's no
yeah.
way we can determine
Okay.
why they called it green.
Okay. Okay. That's interesting. That is
Yeah.
so interesting.
I've always found that this color fluctuates in color. Like it's always
Yeah.
like a little bit blue, a little bit green, depending
Well,
on like the
cobalt is 0.75%.
Yeah.
And that's, I mean,
Small.
a very small percentage.
So if you're a little bit off,
If you're using a scale that's not terribly accurate and you're not making a particularly large batch, that's likely where the variation is coming from.
Yeah.
That would be my guess.
So I have a question too. So it looks like this clay body has the speckles in it. Is that the manganese?
This is
speckle?
reclaimed clay.
It's reclaimed. Okay.
Yep, so it's going to have a little bit of
So could
everything.
that affect stuff too? That affect the crazing and?
So crazing is about fit,
Right.
If you take the same glaze and you apply it to different clay bodies, you're going to get varying degrees of fit. Porcelain's going to shrink more. You're likely not going to see any crazing if you put the same glaze on porcelain. It's really hard to completely eliminate crazing from a really glossy transparent in a situation where you have 20 different clay bodies. You're not going to nail it. If you have one clay body, you can eliminate it. That's just too many variables for making that work. So I'm not terribly concerned about that as a result. But if we could reduce the melt a little bit so that there's less student pots that glaze themselves to the kiln shelf, and possibly reduce the crazing even a little bit, using the reclaim as kind of a catch-all of like the average of shrinkage and fit between all the clay bodies in the studio. imprecise, but
From experience, this would, all of these kind of like had me scared. How much they ran and how much they globbed up at the
yeah,
bottom.
and we can see that the frit
you're
is
just baking.
highly responsible for that melt. And although it's not totally melted, there aren't any signs of crazing here.
So I'm trying to like go back to my notes.
Yes.
So the frits are the stabilizers and the hardeners, or no?
No, frits
So
are
all right.
fluxes.
Frit,
So
the frit
yep,
is the flux.
Yep.
So that fluxed a lot.
yep, yep,
The flux.
yep.
Made
The
it really melt.
the
The
frit
frit did not
is
change in these ones.
Okay.
Yeah, it was the flint that we took out
flint.
of this one.
Yeah,
The flint is the silica.
Yes.
Which
Is the glass former.
Needs, yeah, and
Yep.
it raises the temperature.
Okay.
it does.
Yeah, okay.
Yep. Both silica and alumina are really refractory. They have very high melting temperatures. The alumina is the glass hardener. The silica is the glass former. And then all of the fluxes are what is bringing that melting temperature down to your target. So if you're firing at low temperature, you're going to have a higher flux to silica ratio.
That's why they put the lead in.
Lead or boron or
Right.
the low temperature fluxes. If you have a high fire, you're going to have a lower flux to silica ratio, which makes it easier and cheaper to achieve a durable glass at high temperatures, because you can have more alumina and more silica to make that durable.
Which
You
are cheaper.
can achieve, and cheaper, those are cheaper. If you're paying for frits, they're expensive, and you can get a durable low temperature glaze, but it tends to be using more expensive materials.
And frit is a ground
Manu-
up glaze, right?
It's what?
It's a ground up, like you fire it and then you grind it up? No?
No, it's manufactured. I don't know exactly the process. It may be that they're taking these and they're bonding them and grinding them up. But there's a whole bunch of frits. There's different frit companies, and they all have different ratios of what the fluxes are. 3134 is a zero alumina frit. That's really ideal if you're doing crystalline glazes and trying to grow crystals in the glaze. You don't want alumina, that inhibits crystal growth. So you're choosing different frits depending on your application. Okay, we did a similar thing with the Berks Celadon. Does anybody, Robin or Julie, you don't have notes about where we got with that?
I have partial notes.
Yeah?
Yeah. Not
Do you
on
have
me,
like
though.
the water content for the Berks Celadon? Or the specific gravity, viscosity?
Good question. I didn't bring my partial notes with me, but I
Okay.
will look.
Okay.
I don't. I know. I mean, I have my test tiles, which was the eliminate one ingredient, but I didn't. Get
Out
to
of
the,
which?
So this was the bucket for the spearmint.
Spearmint.
Yeah.
Okay. Do you have notes about the water?
I don't
content?
have the water notes. This is the only. I just have the. That was the bucket. That's the frit. That's the left side. Okay, minus one ingredient.
Great.
So we didn't really do that depth.
Did you do this after that class? I don't remember ever seeing these.
No, this was done in the class.
Oh,
Yeah.
okay.
We had a lot. We had a lot of stuff.
We did.
That we were looking at.
Okay. I want to capture this recipe and information that you have on it. Do you remember what these ones? Okay, minus frit.
Yeah, it says on there. Yeah, they're on the back. Like
Minus
more than that.
Nefsci.
Yeah. Minus EPK.
Minus EPK. Minus rutile. Minus wolastanite. That is weird.
It's on the back. There.
Normal.
I think this one was less water,
Oh, okay.
What is this? Experiment. Yeah, this was the less water.
Okay. So that's not one of the.
One of the water ones. Yeah.
Okay, so it's
Yeah.
that's the.
Yeah. Yeah.
Okay. Cool.
But that one was very interesting.
Yeah.
That got nicely.
Yeah,
covered and
I also think this is
lovely.
quite interesting.
Yeah,
So
the colors are. Yeah,
Yeah.
the colors came out different on every one.
yeah, I don't remember seeing that, but that's fine. That's great to see again. Okay. How are we all doing? Are we caught up? We kind of know where we left off. Are there questions about what we've already covered that you want more refreshment on before we move forward? No?
I
Okay.
can't tell yet.
Okay, that's fine.
Although I think-
Please ask questions because I
think
know
the-
I'm going
the
fast.
only thing I'd get a little bit more on is I've got, I think in my head I'm trying to make sense of I'm looking at that flux, the glass, the hardener.
Yes.
And which ones are which.
Yes.
Is there, I know the batching order is great. Is there something like that? We listed some, like the glass is silica /flint /quartz, and the hardeners are alumina, the
Yeah.
kaolin has silica and alumina.
Yep.
But fluxes, it seemed like there's a lot of fluxes.
Sure. So yes, there are a lot of fluxes. Off the top of my head, the more low temperature fluxes are boron, lithium.
We've got calcium, potassium,
Yep,
sodium,
yep,
manganese,
yep.
Nenside.
Yep.
And then I've got notes on like the feldspars have some of all of the above.
Yep. Yep.
And that.
Yeah, so let me cover a couple of those. Yes, calcium. You can get pure calcium from whiting. You can get calcium silicate as wollastonite. You will see calcium in almost every feldspar and in a lot of frits. Those are the primary, and dolomite. Dolomite is calcium, magnesium, and silica. So those are the sources of calcium. I do know that calcium and all of the fluxes, in addition to just being melters, they can have an effect on the fit, the thermal expansion. They can have an effect on color response. Calcium tends to be a little, let me see, I'm trying to remember. I know that calcium can affect, my boss was making magenta color, and he said shifting the kind of the red spectrum of what to get magenta, it was all about calcium. This is like a little over my head, honestly. He's like making glaze that stays in suspension more or less indefinitely inside of a cartridge for printing on ceramic tile. So like the fake marble tile or wood tile that you get for your showers and stuff, that's what he's working on, is a very like industry kind of stuff that he is actually needing to print in true CMYK that after it gets fired up to cone 6, and those kilns fire up to cone 6 and back down in something something like it's like 90 minutes or something.
Wow.
Yeah, that's very fast.
Yeah, I mean they're like going through tunnel kilns, and so they're blasting through, and so there's like everything from the amount of carbonates in the recipes and off-gassing and like all of that has to be
I'm sure
addressed.
they have to maintain the environment of the room too as well.
Well, it's just a tunnel kiln, so it's like as
Okay.
the cart drives through
Okay.
it goes
Yeah.
hotter and cooler,
Right.
and it comes out the other end ready to unload.
Oh.
So these are
Yeah,
are
it's gonna
things
be all
I've never.
contained,
Yeah, and the kiln's never shut off. So if they have to maintenance the kiln, they have to crawl like under the kiln into the tunnel
As it's on.
as it's on. Yeah, it doesn't turn off, and they're repairing it while it's
Who
still
draws the
functioning.
short straw to crawl into the
Yeah.
okay.
Well, it turns off if they lose their power source, unless they have something, a
Yeah.
generator that keeps it.
My
Probably
friend-
they do.
My friend Dan, who is the production manager for East Fork Pottery in North Carolina, they're a pretty big operation. He was at Alfred with me in the ceramic and glass engineering program, and he was living and working in what's that kind of hellhole in California where they test piloted the credit card, Fresno. Did you ever hear the story about how they test piloted the credit card? They like sent people in the mail in Fresno prepaid credit cards in the mail, and of course people just like drove mailbox to mailbox grabbing all these prepaid credit cards. It was like, oh, that didn't work. Anyway, they had to work out some of the bugs. But when he was there, he was working for a glass company, and they have these like 1,000-gallon crucibles of molten glass, and when they have to do work on it, they have a giant ice lance, and they open the valve in the bottom. They're standing underneath 1,000 gallons of molten glass, and they open it and they take this giant ice lance and they ram it up inside before the glass starts pouring out. Wild.
Doesn't
Doesn't
like shock
sound like
me.
OSHA standard.
Yeah, yeah, just for real.
Is there OSHA in these places?
Yeah, I mean, it's I guess it's how it's done, because turning those things off would just be like, I don't know if you, yeah. Anyway, that's a side note. I digress. What was I talking about?
We were talking about.
Well, we started with silicone.
No, you started with
that's
calcium.
what I meant.
Oh,
Calcium.
calcium.
I'm sorry.
Okay, yeah.
I meant calcium.
Yeah, calcium. Sodium tends to, from my experience, it tends to produce more vibrant colors. It also has the highest kind of thermal expansion, so high sodium glazes tend to craze. If you have a clear glaze and you put it in a soda firing, you're spraying in sodium. And if you have a clear glaze in a soda kiln, it will craze wherever the soda hits it. That's just kind of known. Potassium.
Does the soda hit it at its gas, right? Is it a gas form?
It would be vapor, yeah. So it's mixed, dissolved in water, and the water vaporizes and it carries the sodium with it.
Kind of like in the
Yep.
atmosphere.
Yep, in the atmosphere. So if you see a soda feldspar, there are many soda spars. They will also contain calcium and potassium, but they just tend to lean heavier in the percentage of sodium. Potash feldspars, potassium feldspars are another common feldspar. Potassium, I would need to read more about potassium. It is a pretty common ingredient. Custer feldspar in Custer, South Dakota was the only North American potash feldspar mine that closed. So now we are sourcing, it's called Minspar 200 EU, that we're importing as a replacement that is being used for potash feldspar. From what I've heard, it's a fairly good 1-to-1 ratio. I don't know about pricing for it. I assume with tariffs and whatnot, those prices are going up. Likewise, talc is another ingredient. Those mines closed. North American talc was in Texas talc mine. That got bought and privatized. So there's no domestic talc distributor. And so that's now coming from India. And the price is like, I think at least 3 times more expensive.
Than it used to be.
Than the Texas talc.
Oh.
Yeah, than what it used to be. So importing all of that is increasing the cost of a lot of stuff. Talc, as an ingredient, has a lot of. It's a very interesting ingredient. I believe it has a lot of magnesium. It is a great material for low temperature white earthenware clay bodies. It can make up something like 80% of the clay body can just be talc. And so when that change happened, that was really big for any low temperature ceramic industry.
I thought it was also the common ingredient that made glazes matte.
Magnesium.
Okay.
And it was a cheap and good source of magnesium. Magnesium is a flux, but it also is a good matting agent. Microcrystalline growth of magnesium produces some of the better silky satin mats. You can tell a true matte versus a fake matte if you fire it hotter. A true matte will stay matte. A fake matte is just an under-fired glossy glaze.
Okay.
It's temperature specific, where the other one is less.
One is about crystal growth that's refracting the light, and one is just undeveloped glaze matrix. Yeah.
So is a satin matte a true matte, or is it a fake matte?
Depends on the recipe. I guess you would have to test. Yeah. A under fired glaze is much more likely to stain and potentially leach into your food if you have acidic food. It's not going to be as durable. It'll probably metal mark easier.
Is there some sort of chart or table? I cannot remember these
A
things.
stole chart.
A stole? I mean, you stole it, or is there?
Well,
Is
he
that
sent
a
it to
specific
us.
name?
I sent it to you.
Oh.
But he didn't steal it.
Yeah, so this is what the stole chart looks like. And so it has everywhere in this kind of grayed out area. If you plot your glaze using Glaze and you type in the recipe, it will plot where your glaze lands within this. And so that area,
The X and Y axis is kind of threw me off, though.
You would
'Cause
call that
they're
what?
molecular.
What's the name
Yeah.
of that?
Okay.
yeah, but
Stole chart.
stole
S-T-U-L-L.
chart. STULL.
STU.
Yeah. Yeah, and so it is a way, if you plug it into Glazy and you type in what the ingredients and the percentages are, it does produce a free kind of mark of where your
So
glaze
that'd be
might
kind of
land.
interesting to do with that, is to kind of plug in the recipe that we use to see what it looks like.
It would be
on
great,
stone charts.
and to plug in the recipe
Yeah, yeah.
minus different
Right.
materials
See how
and
that-
see how that tracks
Okay.
with what you actually got.
So
Yeah,
the basic, that's a computer simulation of
yeah, of what you might,
Chemical
you might
reactions.
expect.
huh?
It's approximating the chemical reactions. right?
Yes, yeah. It's not perfect.
So does the stall chart for all glazes fit somewhere, or a certain glaze goes through transformations?
It should be all the glazes.
So there's one universal stall chart.
Yeah.
Okay.
So Isn't temperature a variable on that chart?
That is a good question. It does not have the temperature, but
Does it use like a certain temperature and this is what it would be at?
that's a good question.
Temperature?
That's a good question. I
So
don't
that
know
was
the answer.
coordinates are SIO.
That's silica and alumina. Yeah. So it's looking at the silica and alumina ratio.
Oh, so that's what the XY.
Yeah.
Okay.
Yeah. SiO2 silica, Al2O3 is alumina.
Okay.
Yeah. Okay. And so, yeah, it is extracting the information of how much silica and alumina you're getting from the clays, from the feldspars, from the frits, things like that, and mapping them. So, yeah, there's a lot of information about each of the fluxes. I don't have that in my brain. Bits and pieces.
I'm just trying to,
Yeah.
for my Excel, work it, because we're looking at these concrete examples, eliminating ingredient or tweaking.
Yeah.
So it's interesting just to know, okay, where would I go then to get less melt?
Yes.
So we got less flux. to
So
less
yeah,
melt.
so last term, what we did in addition to the Soto Green, each of those tests, we did the elimination test. We wrote a hypothesis and a conclusion from each round, and then we wrote kind of a materials truth. So this is the cost per pound of those materials, the percent range for Cone 6 glazes. So we flipped through books, we flipped through all the recipes here at the studio. We looked for what is the percentage range that you would typically see of that material at Cone 6. And that way, if you are grabbing a new recipe, it's a way for you to say, like, is this way out of range? Is it like, where is it falling within the spectrum of how we see that material used? The just like chemicals of what each of those ingredients is adding to the recipe, not necessarily percentages, but just this is a source of potassium, or this is a source of silica. And then any notes we had about how those materials are affecting green properties, storage properties, application, firing, or final appearance, based on what we were seeing in those tests and in the buckets.
If you do Google stool charts,
Yeah.
make sure it's STULL, because if you do one L, you get stool charts. It's not what you're looking for.
Pro tip.
Good to know.
Cool, great. Thank you for that.
Yes.
Okay, what I am hoping that we can do for the second round of this course is I would like to do 3 different glaze bases, whether that's the Burke Celadon, the Spearmint, and this one. And we take kind of the best foundation of each of those recipes. And
Which ones you said? 3?
yeah, we'll do the Soto Green, but kind of the recipe as where we left it off. The Burke's Celadon and the Spearmint. And what we're going to do is we are going to take out any of the ingredients that are affecting color, and we're going to see how those bases respond to different inputs of color. So we're going to be initially mixing up 12,000 gram batches of each of those glazes. I can pass a couple of these out.
12,000? Oh, because you're gonna split them on different lines.
Yeah,
Right.
they're going to be getting broken down. 12,000 is what I estimated we would need in order to have batch sizes
Do you
for
have more
different.
copies?
I only
you send
printed
those
3
out?
copies, but I
Yeah.
just sent it out to everyone's email. I just printed off a few, but you can take one of these home. I'm getting a little ahead of myself. Today, I would like to just make batches of each of these, making sure that we have the water percentage. With this one, I thought we could at least take this and see if we can do just a slight reduction of frit to see if we can get that base a little bit better. With the Burke Celadon, I was hoping that we would have the notes of where we left off. So I think we'll just go back to the base recipe here.
I'm not sure that I have any of the early information on that because I started with a different glaze.
Right.
And then I think we converged on that one.
You're right, yeah.
So I think I
Okay.
probably don't, but I will double check.
That's fine. And then, Julie, we'll go ahead and use this spearmint base as
Okay.
well. So we just want to make sure that we have like solid foundation of the water and percentages for each of those. And we are going to make up large batches minus the colorant. So I sent this out. And this are colorant additives. So down here I have the Soto Green base. That one, I target water was 65%. And including water, I did the math for getting 12,000 grams of wet glaze. Depending on the water percentage for each of these, it's going to change, but we need about 12,000 grams of wet glaze. So we're going to make, next week, we're going to make 3 big 5-gallon buckets of these glaze bases
Without the color.
without the color.
And this is copper carbonate?
There's copper and rutile that will be taken out.
Rutile is a color?
It is iron and titanium.
Oh.
What we are going to then do in the following weeks is on week 3, we're going to take those big buckets and we're going to pour them off into 12 quart containers. And we're going to find the saturation point for each of these colors. I took a stab at it. Copper carbonate, I think, reaches saturation at about 4%. Chrome at about 1%. And we can spend a little time kind of verifying, looking through recipes and see, like, are these percentages of colorants at saturation? And we want to plug that information in. Have I lost you guys, or
A little bit, yeah.
little bit? Essentially, what we're going to do of the color. Essentially, what we're going to do is we're going to take the 3 bases. We're going to saturate each of those buckets with one of the colorants. From there, we're going to have a second set of buckets that are at 25% of saturation for each of the color. So for copper, the saturation bucket would be 4% copper in each of these 3 bases. And then the quarter of that would be at 1% copper, the same 3 bases.
How do you know what the saturation point is? It just a chemical property, or
We're
are you
we're
measuring
we're
it
basically we're gonna look through the books and we're going to see what the upper end of the range for each of
somehow?
those
Like what we
colors
did when we said,
are.
oh, this says 12%.
Yeah, so I went on to Digital Fire and they have a lot of that information. When you look at each of the colorants, it says vanadium is seen up to like 10%.
So somebody who is paying for these are saying, hey, I don't want to put any extra whatever color in
The
it. So I'm
colorant
gonna
tends to
figure
be
out,
expensive, yes.
Yeah, the best,
Yeah.
where it stops working, I'm not going to put any more.
Yeah, so I went and bought a couple of colorants that the studio does not have, and like this little half-pound bag of praseodymium was like $25.
Wow.
So yeah, you don't want to use any
No,
more
you
colorant
don't
than
want-
you
yeah.
than you need.
Okay.
So when you're saying we're gonna remove the color, in this case, like we had two different ingredients that
We're
we're
gonna take
creating,
both
so
of
we're
them
taking
out.
both of them out.
Yep.
Okay.
So the new recipe of that is just OM4 ball clay, Minspar, Feldspar, whiting, flint, and frit.
Okay.
So it's only like five ingredients.
And I assume we'll dip that just to see what it looks like as
Yep.
a base.
Yep.
And the assumption is that it should look like this
Yep.
without color.
Yep.
Okay.
Correct. They will all look like clear glazes.
So the two colorings is iron and cobalt,
Yep. And in
And-
here it's rutile and copper.
and without so the coloring acts as a flux too, right? But they're
Not all colorants are fluxes.
No, okay.
Yeah.
But
Copper's a flux.
copper is is it
And-
cobalt? You don't use that much of it.
Yeah, you use a very
You can tell
small-
in this case the color didn't make much of a difference because the actual like texture of the glaze looks pretty consistent with the original.
Right.
It's literally just a color
Yep.
shift. Yeah.
Iron in oxidation is refractory, and in reduction is a flux.
Okay.
So it's not necessarily like it changes.
But you get a
depending on how you
really
buy it.
different color in reduction.
Correct. Yeah. So yes, we're basically going to have three different clear bases, and then we're going to be inputting colors into those bases. So we're going to have a rainbow effect of how these bases are each responding to different color inputs. Does that make sense?
Yes.
Okay. I won't, basically we're going to continue to, once we have buckets of just individual colors, then we're gonna start blending those colors so that each base has 2, 3, or even 4 different colorants going into it. And that's when we're gonna start getting purples and greens and like some unusual colors. And that's going to be towards the end.
Do we expect that the different bases are going to allow us to accomplish sets of different colors in each one?
Yes.
So like use this one trying to get purple is pointless.
Correct.
If you want to get that, use
Yeah,
this
and,
base.
and really that goes back to what Julie's question was, is like, what's the difference between the fluxes? The fluxes are melters, but they do have impacts in color response. And so I'm hoping that we will see that as we compare these different bases. If we have a base that has a lot of frit, or one that has a lot of potassium, like boron or potassium or sodium, that we're going to see how those different fluxes are influencing the color response.
So is this all in oxidation?
Yes.
Okay.
Yep.
We're not using any reduction.
We're doing all cone 6 because it's the only way we can get results back each
in
week.
time,
Yeah.
So we're gonna try for a purple without reduction.
Sure.
Okay. I
Yeah.
didn't know you, it seems
Yeah.
like that red content was due to reduction, but
No, yeah, I mean, you can go buy purple mason stain and get a purple glaze at cone 6.
Okay.
And all that is it's a combination of these things all pre-blended. So we're going to just figure out what these blends
Okay.
are ourselves.
I was learned a little bit when I was taking the other class at WCC. I was trying to get orange and I was trying to get purple, and the purple was very challenging.
Yeah, yeah. I mean,
It's working with
I can say
stains
like
and
this
stuff.
stain, vanadium, is yellow. There's a mason stain called zirconium vanadium blue, and it's like a robin's egg blue using vanadium and zirconium together. So how this behaves in combination with other colorants is going to...
I was mixing different ratios of
Yeah.
this.
Yeah. Yeah.
Can you diagram out for us exactly what you want us to do?
Yes.
today? Like
Yep.
How many grams of this, and
Yep.
what's in, what's not,
Yep.
and all that?
Yep.
Sorry.
So, yes.
Sorry, I'm still caught up on the
That's
color
okay.
here. You said that taking a rutile here took out the color, but to me, this still has
Because
color.
it's got copper carbonate.
Copper and rutile, there's 2 colorants.
Yes.
Right, so that's
Okay.
just the copper.
Yeah, so
But this is without rutile.
yeah, so that's copper.
Okay, and the carbonate here is from the molassanite. I got it, okay.
Yep.
Well, and also the rutile is giving a, the opacity, right?
Yeah, it's the titanium. Rutile is iron and titanium, and the titanium.
I wouldn't have,
Is-
from looking at this test file, known that rutile was giving me color here. Because to me, this is still very colored. I think it's the extraction part that I'm struggling with.
Right, so
But
it's
are you,
minus.
are you
It's the
saying that,
It's the
that
it's the
white is a
difference.
color?
It's the difference here. So the rutile is making the difference. It's adding these kind of more gold tones
Oh, I see.
and the opacity.
Okay.
Okay. I mean,
Yeah,
because
it's making
it's,
it more, slightly more green, which is,
the rutile
I'm not
is that a
seeing-
manufactured?
I'm not seeing one that's minus the copper
I know,
here.
I might be missing the
There's a
top.
test file missing.
Okay, thank you.
Yep. There would be one that would.
This was the original. Okay.
Yeah.
Okay, thank you.
Yeah.
I'm just
Yeah.
thrown off. All right.
No, yeah. And I apologize. Communication is.
I think also the negative part of this throws me off every time. I'm always like, look what frit does, and I'm like, oh no, this one doesn't have frit, and I just get confused because it's like the thing that's missing, it's doing the opposite thing.
Yeah.
Anyway, so
yeah,
all
you're
right.
having to constantly think about the inverse.
In the inverse, yeah.
Yeah. Yeah.
So just one more question.
Yeah.
Mason stain.
Yeah.
So, how, could you use that in everyday ceramics here at the studio? Could I just take Celadon and throw some yellow mason stain in my little piece
Yeah.
and stain my thing? It doesn't affect the way
That's
the glaze is going to
what
work.
I was doing to try and control color, which is
You could take the clear and
Different
add mason
approach.
stain and make whatever color you wanted,
Oh, you
for
could.
example, yeah.
And it's not going to explode.
No.
There's
You know,
some
there's
stuff,
gonna be
there's
like
interesting stuff on Digital Fire
Okay.
where some of the different recipes better encapsulate the color, as I understood. I'm not an expert at this, but that was something to watch out for, is that it's not just a dump in the stain and it'll happen for you. There were some.
So I think what you're referring to is some of the colorants, like cadmium, to produce reds and oranges. It burns out at a pretty low temperature. And so they have a process of encapsulating the pigment, which I think basically means like they're breading it like in a dusting of like silica or something, so that it does not dissipate at higher temperatures. And so those are called encapsulated stains.
Yeah, just the
Um,
takeaway I got from Digital Fire is like nothing is easy.
No,
Nothing,
yeah.
nothing is a one
No.
to one. This will happen. It's
No.
all well. It depends on this, that, or the other
Yeah.
thing, and the temperature, and the blah,
Right.
blah, blah, and
Yes.
what it is. And
So I have to just gather these recipes and input them, but what I can say is for today, the first thing we need to have a bucket of the spearmint recipe made up and identifying how much water. So what that means is checking the specific gravity of what's out here on the floor of the spearmint, and then adding water to this base, making up a batch of spearmint to match, so we know
so
what
just
the
a
water.
plain old batch of spearmint.
Yeah,
Just a 500 gram batch.
500 gram batch. We need to know what the water percentage is. We need to know the water percentage for the Burke Celadon as well.
I feel like,
Do
have
you
that,
have
right?
that?
I didn't bring it. Yeah, I
Oh,
do have
okay.
it at home.
Is it written on any of those test tiles?
The water percentage, well, some of them have the water percentage, but the right ones don't. Like this is 82, it's way 82% water, way too high. What did we start? We started at 70.
70 or 65, I think. One
We
or-
started at 70 and,
Yeah.
it was too high. How was it? My perception, here's where we started.
Yeah.
This was the studio glaze.
Yep,
And I felt like looking at it that it seemed a little bit lighter,
a little thin.
a little thin.
Yeah.
And I have the gravity is 1.53. Of
Okay.
what was the Studio Glaze, but when we looked at my test tiles, this one is 1.9 gravity.
Yeah.
And it just, it's just a little bit, depending what you like, but it does have crazy.
Yeah, yeah.
So we never got to a point of trying to perfect this one because we switched to the Soto Green.
Okay.
But
yeah.
I think 1.53 might be a little thin.
Okay.
But 1.9 maybe is just a little thick, so I don't know what to do with
Okay,
that.
so we need to find out the water percentage, unless you have your notes. It was something like somewhere around 75% water, but I don't totally remember.
Yeah, I
if
think
that's
it was
true.
more like, 70 or a little less, but, we can try it at 70 and go from there.
We're going to test
We're gonna test the specific gravity.
using that.
Yep.
Not one of those.
Yep, yep. And we're going to find out the water percentage for both of these. Here in the Soto Green, I want to take this recipe and make a batch with minus 25% frit and just see if that adjustment will produce a better result. Otherwise, we already have all the information we need there. So we're making 3 buckets of glaze. These two just to identify the base recipe with water percentage. And that one, we're gonna see if we can tweak a little bit. And that will be for today. Does that make sense?
So we're not doing the 12,000 gram.
No, that's gonna be next
Next week, okay.
Yep.
Can you say again about this one? So
Yes.
using the ball
So-
clay only recipe, do something.
Yeah. So I'm gonna read out the recipe.
Okay.
Is it
We're
in the
gonna
notes
do-
that you sent?
Huh?
It's in the notes that you sent though, isn't it?
It is.
Okay.
We're not gonna do all 3 of the frits. I'm just gonna do the slight reduction. So it's gonna be 279 grams of water, 48 grams of OM4 ball clay. Who's in here?
Me. Sorry. I'll look it up.
129 grams of Minspar 200, 15 grams of red iron oxide, 1.8 grams of cobalt carbonate, 65 grams whiting,
I can
49 grams flint, and 121 of frit 3124.
I'll do this one, guys, because I have it here.
Okay.
Okay.
Great. If you want to do that, and you can grab a partner for that. If somebody wants to work with you on that.
Sorry, just to confirm, you've already make the 75% or the 50%
The
one?
75%. So that's just
Can I
the.
just highlight it so that
Yep.
I keep track of what I'm doing?
Yep.
Okay. Oh, not the writing.
I've got the spearmint recipe.
Great, and you have it in the
In the
batching
batch
order.
Where does, I asked you this last time,
Yeah.
I didn't write it down. Where does the rutile fall on this chart?
The
Did
rutile
I
would be
not
with
see it?
colorants,
With colorants?
and
Okay.
it might not be on there, but so
All right.
why don't you come over here, Julie? We'll plug spearmint into this sheet that I'm sharing with everybody.
I'll do it.
And so if somebody can check the specific gravity on the spearmint and check the specific gravity on the Burt Celadon.
So how do you do that?
You
I was gonna say, do it with Keith because he's not there.
Yeah. Somebody want to do this with Keith? How to check specific gravity?
Yeah, I do have my notes because
Hey, girl.
I came to do our first homework assignment. I
Hey.
left them at home. My husband sent them to me. I'm like,
All
okay.
right, you're gonna
But-
save us some time.
So what the Studio Glaze was 1.53 gravity.
Okay.
But I never in my testing got to that.
Yeah.
But
What was the best result? Or do you have?
well, and that's what I'm looking for. I don't
Okay.
have the full. I don't have my notes. But I think 70% water was would have been my and I don't have all my tiles here either. They're a
Okay.
little more, but 70% was higher than 1.53.
We'll check it again.
Yeah.
So we're gonna
So
check
Julie,
the spearmint.
Yeah. Will you check specific gravity of
Yes.
spearmint with
Yes,
Keith?
absolutely.
And kind of walk him through how to do that.
Absolutely.
Cool. And then let
This
me.
is except I got the rutile should go up there.
Okay.
But I think otherwise it's in order.
All right, I'm gonna plug this in.
So I guess we can.
And then
So what do? We fill this
So-
up
I'm
with
gonna
spearmint?
throw in
Okay.
This is my
You don't-
It's,
diagram.
it's gonna be great.
So
Take the same
70%
container,
came up
which
with
is that.
1.5.
Okay.
One is water,
So
and
that's
100
lower,
we
so
have
it's
to
gotta
wait
be
for
more
the
than,
water.
it's gotta be less than
Wait,
70%.
That's why I said,
Yep.
my guess is
And then
water of
it's
like
this over that equals the
68% is
specific
somewhere
Oh,
between
okay.
65 and
So
70.
basically, you could use anything.
Okay.
You
But
could
we can
use
do a quick-
Coke can, but
I mean, I guess
it's
we're
the
not
same
gonna have
amount,
the
so you're just getting the
but we can-
ratio.
Okay,
Start with some
do you
water.
have the recipe in front of you
Yes,
with the batching
I'll hold the
order?
scale.
Okay, I'm gonna plug this all in, and then I can,
Yeah, just, I missed copper
okay,
oxide,
so
so
we
it goes
have,
after zinc oxide.
okay, 1 sec, ball clay is, oh, wait, okay, so then maybe I already have it. Okay, I already plugged that in.
Oh, you have 68%?
Well, you just
Oh, yeah,
told me
okay,
68.
okay.
And you said specific gravity was, we're aiming for like 1.6 or something?
Yeah, yeah.
Is that, what do you do? I just have 100.
And did you have a viscosity reading?
Somewhere, but I don't have the notes for that.
It's fine.
Trying to guess that you guys.
Can you check the viscosity of Celadon?
Yep, yep.
And then let me plug in Spearmint here. They're checking specific gravity, and then we will have to make that. Sorry, delegating all of this. I'm like not doing great at how to do that.
I would need something printed on paper.
Yeah, let me just plug these in, and then I will show you. How's your business running, Robin? Yeah?
Fine. Except for the fact that I moved everything to my house a month ago and my studio's still not done. So I'm out of production at the moment.
Yeah.
Yeah, and just like waiting. It's fine. I have a good amount of stock. But I'm not feeling very patient at the moment.
Yeah.
What's your business?
I make tiles.
Oh.
I took over from someone who had developed a bunch of over 150 designs over about 25 years, and
Oh my goodness.
he wanted to retire, and he wanted somebody to keep making his designs. And I ended up connecting with him, and now it's my business, and it's been
By the way, for all of us,
just
I
a
have
little
this
bit
small
over a
scale
year.
for like really small weights. So
And
I'll
I
just leave
have
this here.
Thank
so
you.
very much to learn. And
You're very brave.
that's one word for it.
Okay.
That's the nice word for it, and I'll take it. I've applied many other words to that choice in the last
I
year.
bet you have if you've been going through it. I can only imagine.
There's a lot of potential. There's a lot of potential in it.
um,
And right now I'm still in like this extended transition
The
period.
viscosity,
who did
this
you
is much,
sell
this didn't run all the way through, I mean, it's pretty
Um,
close, but not all the
So
way
Yeah.
I
through.
have a number
Um,
of
You really use this
galleries that
Well, I mean, it ran
you
if it's
know,
90.
Yeah.
inherited.
Yeah.
You know,
Okay.
But
came
it's
with
much slower than it was
you know, all the
before.
contacts.
Well, we
came
were
with
using
my
the Ford Cup
buying the
before.
business.
No, I use this.
Did you?
So there's a few different ones.
Yeah,
around
and it
the
was
state.
like, I wanna
There's
say
a
like
few across
six,
the
the
country.
Studio Glaze was
And then there's
16.
also
The
people
batch
who
I liked was more
somehow
like
find their way to
18.
my
Uh-huh.
website
But this
and
is
manage to
20,
contact
and
me.
it was
So I do
still
some-
dripping. I mean, it
some
stopped
direct
running through,
consumer
but so it's pretty much, it's
So-
supposed to
Yeah, why don't we
21.
check the
Like, pretty much
specific
anybody
gravity on that
who
to
is
see
working
I
if
think
it's
it's,
thicker?
because it's
or-
also, it's at the bottom of the bucket.
for part of
So-
the
And it's been
comes
months.
directly through
Yeah.
So,
Yeah,
or
so
not
I-
months,
yeah.
but it's been.
No,
Yeah,
would
my
this
sense
be
is
like-
it's a little
this
thicker
would
than
be
it was
for
when I
building
started.
purposes.
Yeah, let's find out. Let's
Yeah.
find out where we're
it's,
at.
I mean, it's like any kind of decorative installation. I can show you
Yeah, just
my-
one example.
my website. So like here's that's the opening page of the website, that fireplace is all
okay.
the field tile and then like the high relief pieces in the middle.
Oh, wow.
Those are all
Okay,
from
that's a really
my
good
company.
example.
This
Okay.
is like a kitchen backsplash. So
That was
so
the
this
first
is
thing
what,
that popped into my head was backsplash.
Yeah, yeah. A lot
We
of
have
those and
a
fireplaces.
fireplace. We have one. That would have been probably my second thought. So.
Yeah.
Okay.
Well, I can find. So before I took this on, I had known about this guy's work because he made a custom tile for a nonprofit that I worked for, and that we would give as an award to volunteers and board members and things like that. And then years later, my parents were building a new place, downsizing, and my mom's like, "Hey, I came across these tiles of this guy in Michigan, and I think you'd really like them." And I was like, "Yeah, I already know all about them, and I love them." So my parents actually have some in their home, and then my mother sent me an article that she came across
261.
about
149
this guy
divided by
retiring and looking for
Was it-
somebody
was
to
it-
take
was
things
it
on, and
49?
she did not
Two-
think she was giving me
Well, that's the
ideas. She just
container.
thought I would
That's
be
149,
interested to
yeah.
know.
So 261.
So that's the fireplace at my
So
parents'
take
place.
261 divided by
Yeah,
149.
so these
149 was
What's
those
the
all
dollar
of that was the
Yeah,
lot.
she was
Well,
wonderful.
that's what,
Yeah.
Yeah.
that's what
Yeah.
Layla said, that
So
you did
the
before you
different
put it
sizes
on
of
there.
field tiles,
Yeah. So
making up the
261
border,
divided by
and then,
149. Let me pull. I can do
and then,
that.
like the high relief
Yeah.
pieces.
Nice.
So this is what he spent
1.75.
time developing, is all of these different designs
That doesn't
of
sound
high
right.
relief.
Very nice.
No?
Yeah.
No.
So that's my that's
Well,
my,
isn't it, I mean, we
World
just
of-
measured it. So.
Our last,
That I'm
the
trying to
bucket
figure
one
out
could be
these
different
days.
now. When we were doing it, I got 1.39,
Show
Rosie
you
got
a few that I
1.47.
did.
So
That's
it's
way
just-
off.
That I
Yeah.
made in my
I
car.
would love to
Oh,
see
Yeah,
it.
1.4.
It was
I have,
approximately
I have
1.4.
little other ceramic.
How
pieces
could it be
Okay.
that far off?
And I
Well,
thought
if
when
it's
I got
is
in
it
touch with
is the
my
bucket near empty?
draw and paint as well.
Yeah, well,
This is
no.
one I
Well,
made
that-
for
I
my
did it really
wedding,
well.
for my
That's-
daughter for
and it's not-
Christmas.
yeah.
That's
No,
very
it's-
sweet. I love it.
Oh,
Okay. Here's one where I actually I made the base. This
And
is
you got
stained.
that orange? Okay.
I didn't do the orange.
Okay.
The orange is stained. I did the other.
Yeah, I mean that
Is all-
container's
Is that
149.
speckle from your glaze, or is
Did
it
you
from
zero
your
the
clay
scale
body?
up?
I think it has
Filling it?
more to do with the clay
Yeah.
body, to
yeah.
be honest.
Okay.
Here's
Oh,
one that
that's
I.
lovely.
Yeah, a lot
I
of
really
people like
enjoy
that.
that, yeah.
These were ones where we did them. I forget. There's a name. I can never remember the name. Like in 40 minutes or less outside with a fire. They're not. You can't drink them or whatever. But
Yeah, yeah.
It was. Shoot, I wish I could remember. Here's a nice result. that
Really,
I got
yeah, I really
here.
enjoy the overlapping.
Here's one that I did here. And
Ooh,
this one
that's
came
nice.
out through. Yeah. This all I did was actually dip the top, and then it just ran like that on top of the glaze. It
Was
a-
the scale zeroed?
No, I don't
I
know.
think
Well,
that's about.
Did
I don't know.
you
I
measure the
did-
container
I
did-
and
I-
then
this-
fill
I
it
this
in?
made
was-
this.
was
I
not
still
zero.
have not stained this
You
one yet.
haven't?
I was trying to get an orange. I have like 3 or 4 pieces that I made like a year ago that I
Yeah.
still haven't stained.
Yeah.
Because it's like, I know what I want in this orange or whatever. And that's what I was working
So,
on
okay,
orange
yeah.
in the class. And stuff.
Nice.
But
That's cool.
yeah, I have a ton of pieces. But those are some of my favorite ones.
Yeah, that's really cool. I love it.
So, I've done. I took a class when I was in like either I think it was my senior year in high school, where I first worked with clay
Okay,
and made
nice.
some pieces there,
Nice.
and then a couple
Okay,
years ago, I
1.42.
started to-
So we need to find out what our water percentage on that is.
So
So,
maybe you wanna write 182 on
playing
it.
around with the glaze.
I'm gonna do 1.42 specific gravity. So what we need to do is make up a batch of spearmint
I've only been in 2 throwing classes here. And
with starting with
I think
65%
it
water.
was,
65% water,
this
okay.
effect
And
was much
then
worse the second time.
You're going
where
to
I,
mix it up
I was
and
being
then measure
overly
the bottle weight
perfectionist about
and
what
see how
and I
close
made
that comes
almost
to
nothing.
1.42.
my whole
Exactly.
class. And I can't wait to do another drawing class.
Are you
Just
done with the
focus
class
on
for right now?
volume.
Sure,
Yeah.
yeah.
I
And then
had
I
an
just
art
check
teacher, a
Already,
painting
yeah.
teacher.
Well,
when
with
she was
water, it's
talking
So you-
about,
182,
like,
so-
painting, establishing a regular practice, she said,
Uh,
"Have you ever
Okay,
thought?"
so I just do
just
it,
do, just
whatever
mix stuff.
container you have, I measure a
never all
container
gonna
of
be
water
good.
and
It's
container
never
of
all gonna
place
be
and
the
Yeah.
best.
separation.
And that's stuff
Yeah.
that
It doesn't matter what
next time I do
container
a
it is.
science
Right.
class, that's gonna be my
Well,
mark.
it doesn't matter
Quantity over
Yeah.
quality.
what container you use.
Because for me,
It's just the
with
ratio.
my
Yeah.
drawing at
Sorry,
least,
it's
that's
just-
just,
Oh, I'm like,
Sorry.
no,
So with
That's
with
where I
Glaze
go.
in that container, with the container zeroed out ahead of time, you got around 211.
261.
Finally got programmed.
261 divided by 183 is
The
132.
grade set, from Microsoft.
Mhm.
Okay, so that's
Fail
included in the weight of the
fast.
container.
Yeah.
Failing fast.
yes.
Okay.
Yeah.
You know, and,
Yeah,
and
just
when
do
I
it.
first started, it's,
Okay.
I'm a perfectionist. You probably
I-
are too,
I-
based on
yes.
that
Okay,
you can't
that's where I'm
even
getting
make
confused.
Oh,
Yeah.
right, I
one
didn't
pot
zero it out.
work.
It was, I zeroed it
When I
out
first
before I put the
started,
whole
I had
thing
trouble
on.
doing the balancing and all the basic stuff.
Yeah.
Right.
You
So
know,
yeah,
what's
I
in
usually
the
zero,
three classes
put the container
when I
on
first
zero
started
it.
Okay,
getting
we
to
just
it,
measured
I
the whole
could
thing to get
That's
the
where the
ratio.
numbers are.
But then when
Okay.
I got it,
Oh,
I
okay,
made five
so
pieces
one
in one
is with the
class.
tear.
Yeah, that's
You know,
Yeah,
right.
it was
yeah. I
zero,
usually
zero,
tear out
zero,
the
Okay.
container
Yeah.
before
Well,
I
And
measure
it's
it.
like
That's why these
3
numbers are
That's the ratio.
sounding weird.
Okay.
So,
But the
you
ratio
have
is still
you
gonna
have
be
to
the
do
same.
that.
Right.
Now,
Yeah.
you know, when you
Okay.
think like, I'll
Um,
never get to do this again.
So,
You gotta just.
you have the batching order, you have the numbers.
Been working
So
in
starting with
the-
65%
the
water,
original
mix
tile
that up,
studio in Jackson for
and
a
then
year.
check the
And
specific
trying
gravity
get
to
the studio
see
built at my
Yeah,
home.
you.
how close
And
you
so
are
now I
to
will
the
have
target.
opportunity, like,
Okay.
after I
So
do
that make sense?
325,
if I wanted to, I could get
65% of 500.
500 home.
So
And
320
so I'm
yeah.
really excited about that.
That's why.
Yeah, that's like the dream.
grams of water.
Facilities,
325 grams of water we start
Yes.
with. Okay, got it.
Yeah.
So,
WCCA.
why don't you two do that
Three
together?
hundred.
325 grams of water.
Yep.
600.
And then you have
And
your-
get 15
you have your
weeks.
Start with
numbers.
the water.
Two classes.
Yep,
Yeah.
start with the water.
Two classes.
And
Sully's
You get
already
3
has the
hours.
batching
They'll
order.
fit in the quart.
Every
Yes.
week.
Yep.
I
So
brought
inside
some.
of
I
that,
brought some.
Monday, Tuesday,
Okay.
Wednesday, Thursday. Between, because they have 2
And
classes.
I
12,
just have to kind of
3,
get
3:30, and
get my
6.
notes here set up
9,
for.
whatever.
This
But
is
that,
zero out.
the time in between 3:30 and 6 is open.
This.
Every day you can go in and
That's
do
pretty
whatever you
excellent,
want.
yeah.
So yeah, I mean, it was, I paid for the class and I get 6 hours
Yeah,
a day or 3 on Tuesday,
Yeah.
Thursday.
Okay.
You know,
Yeah,
and
that's
you
really
can
good.
focus on whatever you want. And I mean, when you take class 1, you have to work with specific stuff. Class 2, and you're trying to be more on the wheel and stuff. But now I've taken class 2, and it's like class 3 every 4 or 5 times. And then you just talk to the instructor and say, this is what I want to learn, this is what I want to get out of this class.
Yeah,
And
nice.
you don't have all the assignments and stuff,
Yeah.
so it's working.
That's really
So
cool.
you subtract the weight of the thing, so you get the actual weight of the materials in the water. Okay, I got it.
Yep.
I think that, I can see how that would be really helpful to learn from multiple sources. Yeah.
First instructor was awesome. His job was working for one of the main car companies and designing the shape of the
Yeah.
vehicle.
They'd like do the modeling for all of
Yeah,
that. Yeah.
and he was awesome. And the second guy that I got was a teacher. But they all had different skill sets. They all had different approaches. Everyone something different. The other one just got a little harder. He's the one
Have you already
who did
begun
that.
mixing up
It's
first?
not the Waco, but it's something like that. The ones I showed you that were,
Yeah. Yeah.
but
Nice.
you know, and
I'm wondering-
their approach to that.
I'm wondering if we,
I can do
like, now would be the time if we want to actually do a base that is like a satin matte base.
That'd be nice.
Okay, yeah, that makes, I was thinking that, maybe
It's
that's
like-
because.
Yeah?
I would be very.
You'd prefer that.
They have a certain skill set,
Okay.
which is pretty.
Hey guys, we're going to make a quick change, and I'm going to swap out the Burke Celadon for like a satin matte, so that I think we'll see a more interesting finished result.
More
Yeah, that's a
variation
great
in
idea. I
our
was actually gonna say,
bases.
can I do purple? Because I was
You
gonna
want-
volunteer to just do purple because I wanted to see a matte color.
Let's swap out the Burke Celadon for the purple base.
Amazing.
Do you have your notes about the batching order and water percentage on purple?
I have them at home. I could ask my husband to just like take a photo.
That'd be great.
Yeah.
And I'll plug that
This
in.
is a great husband you have.
Oh yeah.
Okay.
Wonderful. I'll
Yeah.
be right back.
Okay. Sorry for the last minute change, but I
okay.
figure now,
Yes,
before
please,
we
thank
invest
you.
a bunch of time,
Yes.
these are all
Purple
kind of
base, and
similar.
What did you say that one was?
It's just purple.
That's what it's
Purple.
called.
It's
Oh.
called purple. So I'm going to swap out Burke Celadon. So we're going to do spearmint, the Soto green, and purple. And we already have Layla's notes on the purple.
Yeah.
But you mentioned some of the core ingredients or whatever in the base for the purple.
Oh.
Because I thought we were gonna start with like white. or
There- yeah.
clear Oh, you're just doing the base,
The
not
base.
the color.
We'll use, yeah.
Yep. I just
The base
I
is
got
right
different.
right now I'm thinking that's going to be more interesting as we plug and play different colors. If we have
I
a
love purple,
satin
so-
matte.
Satin matte. That's what I was looking for.
Yeah.
Shoot. So you're, for the gravity, you're dividing the, okay, so I was looking, I do have the original measured 231 grams. This is measuring 235 grams. So it's 4 grams heavier.
Not much, but
Not
yeah,
much.
a little
and
bit.
And you divide it by, last time I divided by 151, but this one you said is 149. It's right now.
Yeah.
I need to go check in my car for a mask.
Um,
Going
if
to be useful, I think.
yeah, there may be some paper masks under the front desk as
Okay.
well.
Okay, I'll go check.
If you don't have a mask,
I
let me
can't
know.
stay after, and so I was like, I don't need my respirator.
No,
Yeah.
they do have my
Okay.
pickup.
I might have one.
Right, 1.58 versus 1.53 is weird.
I brought everything but my mask. everything but my mask.
You were looking at 1.5.
Yeah, when I measured the Burke Celadon, when I started last time, the bucket was full, and the gravity was 1.53. Now the bucket's is like, there's only 20% in there, and the gravity's 1.58. So it went from 1.53 to 1.58. So, although my favorite tile is the one that's at 1.9. But
So that's less water.
yeah, less water. You know, if I was making it up myself, I would probably shoot for a 1.6 and see how I like it.
Interesting, because the stuff I was doing was like 1.45, 1.48, 45 to top.
Okay, so Layla's got her notes on purple, but what do you need for?
Okay, let me see. I have felt it. Okay, and then
Yeah, thank you.
well, you did the Gersley board, right?
Yes. Because she had said to you, that's what they use here.
Yeah, Gersley borate, and then soda feldspar. So that was the Minspar 200, right?
Mhm.
Okay. Golden
Where
light.
did you say they might be?
Flint,
I've used this only once.
right? I'm picking up the tolerance there. Yeah.
Yeah,
I
the
guess
cobalt probably
I can be a clean. I can be on cleanup duty.
One, two. So I think we need to do elimination tests, or you don't want to bother doing anything here with this one?
I think we're gonna just roll with it without the elimination test. If there's a time that you want to do that, that's fine. But let me just get these percentages. Ball play. Oh, I can grab the percentages here. Do we have the water?
65 was like the one that, 65 was the one that matched the studio.
Do you have a specific gravity on that?
1.59.
Thank you. Okay. Did you have a viscosity on that?
26 seconds.
Okay. Cool. Thank you. Okay. Talc.
What do you want to call? Sorry.
Here's the fluoride. What?
What do you want to call this guy?
It was just calling it Soda Green new base. Or
It was. I forget what we did. Okay, I'll just go.
or you could do, let's see, that's version 1, version 2, version 3. So this would be V4. Yep. Firstly, borate. Okay, sorry guys. I feel like I'm not communicating or delegating, but
Okay.
Flint. Okay, so what we have is
We'll go sit on the other side.
32. Okay, I am almost with you. Cool. So what I have to do here, I'm going to recalculate this so that the batch equals 100%. But we have all the information we need for the purple base.
Okay.
We have all the information we need for the Soda Green new base. Layla's just making the version 4 with the adjustment, so we'll just look at that test file for next week. The purple, we don't need anything between now and next week. And the spearmint, we're making up a batch to identify the water. So for next week, we'll have the water, the batching order, and the base recipes all locked in.
Okay.
And so next week, we're gonna take each of those and make large 5-gallon bucket batches that we will then use to divide up to make our big rainbow.
Okay.
Does that sound good?
Yeah, so we don't need the purple because Layla's got the notes.
She has the notes. Yeah. Which is great. Everybody has access to this sheet. What would be nice is if you have time for any homework, I'm going to plug in the other ingredients that are in each of these 3 recipes. And if you are able to go on the Rovin's website and plug in cost, if you're able to go on to Digital Fire and any notes that you see about any of the listed ingredients, this is the last tab of Glaze elimination test, so it's
Okay.
material truths. So any information you're able to capture would be
So that
helpful.
would be through a web address that you could send.
I sent you an email that had a bunch
Yes, for-
of links and it gave you access to edit.
Where's the
You said
Excel
that, like-
sheet at?
Huh?
Where's the Excel sheet at on one of these?
It should say Glaze elimination test. Should have a little,
Oh, okay.
and then it's the last tab called material truths.
Okay, so you're gonna add things to there and we can fill in.
Yeah.
Okay.
So using Digital Fire, looking at Rovin's website, any information, we just kind of want to like capture as much information as we think we know about these materials. And that's like just a living document
Okay.
that is really nice as a reference. Because sometimes reading
Yeah.
Digital Fire, it's so much information that it just is overwhelming. So I'm trying to make it like little bullet points of like how it's affecting different life stages of the glaze.
Okay. That sounds great.
Sound good?
Yep.
Okay, so for next week, hopefully we'll have at least a good head start on the material truths we'll have the result here, and we'll have the water content figured out,
Okay.
and then we'll go from there. Let's see. I'm going to, yeah, if you want to even start plugging in material truths and looking at specifically the percentages that are common for those ingredients.
Sure.
And the way we're doing that is looking specifically at Cone 6 recipes, so grabbing some of the Glaze books, flipping through them, and plotting that in.
Okay.
So I'm going to start adding those additional materials right now, and in the last half hour of class, if you want to start plugging that in, that would be awesome. Let's see. There's like borate. We have dolomite.
I think I sort of, the ones I put back, I put them all in a, yeah, sort of.
Have nepheline cyanide.
Yeah.
Okay, cool. So all those are in there. I am just zeroing out the purple recipe so that next week we'll have all the numbers we need.
We did soda, we did the material ranges for soda, the soda green materials.
Yep,
last year,
we
didn't
did that. Yep.
Okay.
Yep, so the new, it looks like Layla's plugging in the price. So we're looking for a percent range for talc, Gersley borate, dolomite, nepheline cyanide, elastite, and ferrofrit 3195. And then kind of the chemical makeup of those, and then any notes.
Is it possible Rovan doesn't sell elastomite, or do they just sell it under a different name?
I would be surprised if they didn't sell it. I don't know it as another name, unless it's calcium silicate, maybe. That's like the chemical of what it is.
Yeah, it's not coming up at all.
You could look on Laguna's website. You could look on Runyon's website.
Elastomite 30 or 10? I think the 10.
I think W30.
Oh.
page on exactly what we're doing. How to expand a palette.
Yeah.
Really? Wow.
Yep.
Nice.
So there's that book. There's also Robin Hopper's The Ceramic Spectrum, which is essentially what we're doing in this class. Right here. So this is a great book that is talking about, instead of doing triaxial blends, we are going to be using a Taguchi orthogonal array, which is essentially a less accurate, but it requires a lot fewer tests. There's like more space between each result.
Which gives you probably a broader scope of what you can look at.
Yeah,
Well, you really want to zero in.
yeah, if you want to
Where-
zero
where is it
in,
when?
then you would do something like
Okay.
a triaxial blend. But I feel like when you're first exploring, it's good to like do big picture and then zoom in and zoom in as you're getting closer to the result you're looking for. But with the you get the same kind of like overall amount of information with the Taguchi orthogonal array with 9 tests that you would get with like 36 tests if you were to do a quadraxial blend. So it saves you a lot of time.
Okay, class bonus. Does
What
anybody,
is
I
that?
found a bunch of these at Kiwanis. Does anybody want one? They're only 50 millimeters. They're not 100, but that can help you. Would anybody like one for their
That's
very
awesome.
own? They're lightweight.
Sure.
Yeah.
If you're, really.
That's cool.
Thank you.
Sometimes I just find stuff.
Amazing.
There they were. There they were in a bin. Yeah, they're pretty lightweight, but they can.
Did we already find out how much water the spearmint required?
I added another 50, so it's at 375 right now, and it's goopy. So that's at 375 because it was really goopy.
So,
375 grams.
and
of
is
water.
that the correct specific gravity?
I don't think so. No.
Okay,
We,
so we're
we didn't measure the gravity yet.
okay. So we're still working on getting that.
Did you want one, Bill?
No, well, okay. Well, again,
Yes, want one of their very own.
can't hurt. Yeah, yeah.
Might as well.
Might as
Take
well.
advantage. Your very own 50 milliliter thing.
Okay, purple, and this is experiment. Okay, so we have Soto green, 65% water, purple, also 65% water. I have the specific gravities recorded. I have on this colorant additive test sheet down at the bottom, I have the base recipes written in the correct batching order without the colorants. So that's what we're going to be using next week for making the big buckets. I did it where it's the dry materials and then the total batch after it's wet. Basically, that allows you to make a lot of tests without having to strain each one. That we're just straining the whole batch,
More water in here?
and that just is going to make it go much faster for testing
I know
purposes.
local waters, the water's 183. I'll weigh that.
And we need to know all that information about water percentage so that when we're adding colorants to the small batches, that we're adding the percentage relative to only the dry material that's in that bucket. Otherwise, you would add way too much colorant if you were accounting for water.
Can I add more water because I know that this is too goopy?
Yeah.
Is that all right?
Yeah.
Okay. I'm gonna add another 50 before I measure.
Yeah, just yeah. And once you get to something that feels usable, then we'll check the specific gravity and see if you get to 1.42, and then we'll know. Great. We have a good foundation. Let me see if there's anything else I said I was going to cover today. I was talking fast. Keith, You are our guinea pig. So what questions are you still scratching your head on about batching order, about measuring specific gravity, about measuring viscosity?
Yeah.
Well, okay, so I specific gravity is just a ratio to solids to water.
Yeah.
Right? Okay. And as far as measuring this, so basically you fill it up and you time it.
Yep. You time it and you start stopwatch, and as soon as all the fluid flows out the bottom, you stop the timer. You always want to use the same viscosity cup, so you wouldn't want to switch back and forth between those. It's a relative test. There's not a true and
Absolute.
accurate absolute number, but it's knowing, yeah, it's like a different size container, a different orifice.
Cold.
Yeah. Yeah, this was for measuring motor oil. That's how you get like 10W30 or 10W40
Oh, I see.
or 20.
Okay.
Yeah, so those numbers are relative to flow.
And the name includes Ford.
Yeah, Ford cup. Yeah.
That's why that's there too.
Yeah. So yeah, it's the flow or
Probably
the.
need to put more in there.
I'm gonna go weigh this one. Well, yeah, we'll probably, I'm guessing we will need more water.
Yeah.
Because the one in the bucket is.
So you're up to 425
It's up to
grams?
425, yeah.
Okay.
And I do have a note that said 1-to-1, so it could possibly be close
Be,
to 1-to-1.
okay.
100% water, yeah.
Well, we'll get there. Once we have that number, we're in
All
good
right.
shape. Okay, so does that make sense?
Yes, that
how-
makes
how
sense.
that works?
Okay, so that's
So,
what else do I
so
have?
just to talk about viscosity a little bit more, the percentage water doesn't necessarily mean that the flow is going to be different, right? It is based on the makeup of the recipe.
If
And
it has a lot more clay in it.
it has a lot more clay in
It'll
it.
be thicker.
Yeah, correct, and it's going to require more water.
Right.
And there are also materials that like to clump. There are some materials that have deflocculant properties that actually help the flow. Like lithium carbonate is both a flux and it also deflocculates a glaze.
No.
Whereas Gersley borate or Gillespie borate, those tend to gel up and thicken the glaze. In addition to being a flux.
So, like, bentonite is a clay, but it's also kind of,
It's a clay.
It's
It's a
a-
super
it'll-
plastic clay.
right.
So it's super hydrophobic. It's really hard to get wet.
But there's clay that people eat. It's the same
Bentonite, I know that you can buy it as like a clay face mask.
Oh, okay.
And you're gonna pay top dollar if you if you buy it through a cosmetic company.
Okay. But yeah, I see
Usually
what you're saying.
bentonite is put as an additive, like below, it's like 100%, and then you'll see colorants and bentonite. And bentonite is often added after the fact to glazes that are settling
I see. Right.
as a way to, as a
Deflock it.
suspension aid. So if you see, like, crystalline glazes are like as low alumina as possible, which means very low or no clay content, which means that they're really difficult to apply and they settle. So often they'll just add bentonite or gum to help keep crystalline glazes.
The clay also helps keep
Adhere
it
it.
on
Yep.
the pot
Yep.
itself and
Yep.
makes it
It has adhesion properties.
right. And it
Yeah.
is otherwise it's just like powder, right?
Yeah,
it's
it's
like a
chalky.
a coating of powder
Correct.
that'll come right off.
Correct.
In my industry, they buy it as like little pellets and they use it when they're installing groundwater monitoring wells to have like a sealant.
The bentonite?
Yeah.
Oh, they to
You
seal
buy it in
up
like 50-pound bags.
seal up a hole.
Yeah, exactly.
Some people use it if they make like wildlife ponds and stuff at home to seal.
Yeah,
the
same
bottom.
idea, exactly.
Oh yeah. It's just
Seal the water.
Yeah, like there's areas where I
Leaking
don't
it.
want
As long
like
as it
surface
doesn't
water
dry
to
out.
come through,
Go.
so I'll use
Be a
bentonite
barrier.
there. Yeah.
Okay. Yeah, it's like a slime coat.
basically.
And if you ever
And it's
just put
such a
bentonite in
pain to
water,
deal with,
it's
'cause, like, if it-
super gooey and like
It's
slimy.
the most disgusting thing to work with because sometimes it's not hydrated well when they're pouring it, so they put too much and it really expands when it hydrates, and so it's just like gushing out of everywhere. And like literally, I will like scoop it out and like just take the glove off because there's no redeeming that glove. Like after
Yeah.
you put bentonite.
No, yeah, it's like digging in boogers.
yeah,
Yeah.
it's so gross. Yeah.
Yeah. But it's super effective.
Yeah.
It's like great at what it does.
And there's
Uh,
some that you can even buy them like these really pellety ones. Like there's ones that will take a couple days to expand and fully, but then we buy these pellet ones that are slightly hydrophobic, so they'll actually settle and then expand. Because I need really to make sure that it's like expanded all the way.
You don't want
There's,
it
like, a
to
variety
expand
of-
on the surface.
which is like called bridging, which is a problem when you're installing wells too. Yeah, there's a bunch of issues. Yeah,
It's called
so
bridging.
yes, it's like your like clay is bridged, and now you have like a gap where you can't get your sand down because you want your sand on your screen, but you want the rest of the pipe to be
Yeah,
yeah.
that makes sense.
Yes,
Are you a civil engineer?
I'm a geologist.
Oh, I see.
This is fascinating. And I'm trying to remember. I feel like is bentonite one of the ingredients in like fracking slurry?
Yeah, it could totally be.
Yeah.
Yeah.
Yeah. Interesting.
Do you have the numbers? I can start putting them in. I have.
Oh, yeah, I couldn't input them on my phone.
Yeah.
The material for talc,
Yeah.
the ranges I found were 3 to 16%.
Okay.
For Gersley borate, I
Where you want to
found
be?
3% to 49%. Gersley
Wow.
borate is all over the map. And then I did dolomite,
Did you get it?
was 3 to 24%.
There.
Okay.
I think we had all the other ingredients from the.
There's a few we don't. The nepheline cyanite, the wollastonite, and the frit 3195.
Okay.
Do you have ranges for some of these? Because I can adjust
I
them.
do. For nepheline cyanite, I've seen 19 to
The one
45.
out, we were making glazes, we'd always sieve them. We don't have to do that.
Not to
What else
get
did you
the
need?
ratio.
Wollastonite?
I see.
Yeah.
The ratio
I've
is not
seen
going to
8
change.
to
You would
20.
want to set it for application.
Right.
Okay.
And
To
I've
apply
only,
it.
I've only
Yeah.
found one with talc, and it
But
was
if you're just
16.7.
dialing it in
That's
for-
all
Okay,
we're
she's
doing
already got
right
that.
now.
Okay.
Okay.
And I didn't find any with. I haven't seen
As
for
long as
Frit
you stir it,
3195.
you get
Okay. Did you do
Yeah, if
Grizzly
you had a
Warrior
big
dolomite?
chunk of
Yeah.
just let it. that
Yes,
would-
I've only seen
No,
one
yes.
dolomite, and it was
Has
20.
to be consistent.
And the Gersley
Yeah.
borate,
In
I've
terms of
seen
weight.
4.2
At least
to
I've never
27 so
seen
She's
far.
got those ranges.
Okay.
Okay.
Civic make a,
Make a big difference in that.
in this scenario.
Yeah.
Yeah.
You know, it's interesting when you're looking at the percentages too, though. Like in those books, you see the glaze, like the one with the Gersley borate super high was milky, like a really milky color. And it's like, you know, and then you look at the ones which is a little, it's like,
Yeah.
when you're looking at the percentage, you can see how it impacts the result.
Yeah. I'm glad that we went ahead and switched. I think it'll be nice to have a satin mat.
Agreed.
And then that one we've already done extensive testing, and this one has some interesting.
I like that color a lot because I like the variation that we're getting from.
Yeah, I think a lot of that's probably coming from the rutile, given that that's actually kind of what the glaze looks like.
Yeah, and that one also reminds me a lot of like a better version of this one.
Yeah.
Yeah, yeah.
I
I
think
feel like
it's
we
a better
talked about
version
that
of
in the
that.
class
Yeah.
too, when she tested it, and we were like, but that looks like
1.42
But like less problematic. Yeah.
grams of water, 450.
450, which is 90%.
Yeah.
Wow, that's super hydrated.
Okay, great. That is all plugged. Thank you.
So we're keeping this, right? We're keeping this. We're not dumping it back in the bucket.
You should test it to make sure it looks right, and then if it looks right, you can dump it. I would think.
You're right. Wouldn't dump it before we test it.
I mean,
But
I would
we're
dump it back
keeping
in the
this one 'cause
bucket.
We're doing stuff with it, right?
We're not really.
Not really, okay.
That we really just needed to know the correct water.
Okay. So
But let's keep it
okay.
because we don't have the viscosity and we'll let it sit.
Okay.
So we might as well sieve it and let it sit, and then next week we'll check the viscosity,
Okay.
and then we'll have all the information we need.
All right. I will do that.
And then we can just pour it into the community bucket. So if you sieve it, dip a test towel so that we know that it looks correct. then we can just put it back into the studio.
Very good.
36 plus 30. Okay. Is 0.9. Got it. And then this has to go down. 65.
So, I got a question. on
Yes.
Majolica glaze, right?
What?
Majolica or Mahalica, how?
Myolica?
Malaya.
Myolica.
Malaya.
Myolica.
Myalica
Yeah.
glaze, right? That's a tin white,
Yeah.
right? And then you paint color oxides
You
over it.
you sinter the glaze onto the pot. So Myolica, Italian Myolica, low fire, super opaque, opacified white. You put on earthenware,
And
like
it's tin,
terracotta.
it's used tin, right?
I think traditionally.
Yeah.
Yep, I think now it's probably switched to Zircopax just because it's cheaper.
It's cheap.
But yeah, it would be a tin white, like a really high percentage, like 15-20% tin. And you put it on the pot and you sinter it, so you like re-bisque fire,
Okay, okay.
so that then you can take stains and you can brush stains on top of it, and then you fire it up to temperature and the stains melt into the opaque
Okay,
white.
okay.
Yeah.
So,
And usually the stains have like the stain colorant and some Gersley borate to help that pigment flux into the glaze below.
and
it.
the stain could be just an oxide, right?
Yep,
Yeah.
yep. It can be mason stain, it could be oxides. There's
So
a
when
long
we were
history of
doing it
knowledge
in
of
our,
stuff.
in a low fire class that we had here, we weren't doing that, bisque fire between it, so we were just painting it directly onto the glaze. So I can see how that would work a lot better to fire it, but, because then it wouldn't, the tin wouldn't come on.
Right.
Yeah.
So yeah, so right here I have, here is our spearmint base without the colorants, 90% water, and that is going to be the batch. So these 3 boxes down at the bottom are the batches we're mixing up next week. And after those, then we're gonna pour them into, I got a whole bunch of containers. And so we're gonna start pouring. So the material truths, and then next week in class, we will start digging up and adding to the material truths information about the colorants themselves, whether they're fluxes, the cost of them, and the kind of percentages that we're seeing those colorants in recipes. Sound good?
Mm-hmm.
Awesome.
Do we need to make some test files?
We have next week.
Next
Next
week,
week, I think I did have that extrude test files today, but forgot. So next
We
week.
need more than what we made last semester.
So yes,
There's pens back there,
there's
so
a lot. So what I did here is I wrote how many test tiles that we would need. So next week, or we'll need 72 test tiles on week 3. We'll need another 27 test tiles week 4,
Okay.
and another 27 test tiles week 5.
So,
Did we make enough?
No.
No.
sounds like we should.
So
These
next
test
week,
tiles?
yeah. So next week we'll have to make more test tiles. We'll,
was this extruded?
yeah.
Yes.
Yep. So we'll extrude and cut them up. So that'll be part of next week as well.
Perfect.
And
Thank
using 2 different clay bodies.
It is a clay body with white slip dipped over
Oh, I
one
see.
half, so that we're seeing what that glaze would look like over a white versus a buff clay body. Cool. And then Layla, can you bring in your purple test tiles? Do you have those?
No, I left them here. Did we throw them
There's
out?
like a whole bucket that disappeared. So along with like some of these.
Yeah, there were 2 buckets of glazed tiles that were
Yeah.
up there.
Yeah, I don't know what happened to them, but
The one at the very top, those are the.
those are
Those
just
are all tests.
Yeah, those are the test.
Blank.
yeah. Okay, it's fine. Julie, can I put those into here?
Yeah, absolutely. I'll save that.
Okay, great. Thank you all.
Do you want these somewhere else then, since we're not using them this time?
I'll be around.
Let's just put them in here. It's incomplete, but maybe at some point
Do
we
you want mine? I
will.
can bring my notes for the ones that, we don't have all of mine, but I can bring my notes so we.
Yeah,
I can
if-
maybe
if
I'll,
there
maybe
are-
I'll type out my notes.
If there are notes on it, that's great.
I'll just keep it in.